Welcome to Severe Weather Analysis for AEST Rock on Saturday, November 22nd, 2025. If you find this analysis helpful, please like and subscribe to support continued severe weather analysis. Let's examine what the atmosphere has in store for Australia's iconic red centre. Looking at our morning sounding taken at 10 a.m. local time, we are seeing a classic arid environment profile. The red temperature line shows surface temperatures already at 29 degrees Celsius with a dew point around 12 degrees, giving us a large temperature dew point spread of 17 degrees. This dry air signature is typical for the outback. Notice how the green dew point line diverges sharply from the temperature. That gap represents just 23 millimeters of precipitable water. The mixed layer CAPE sits at 0 joules per kilogram this morning because there's a substantial cap in place. Looking at the enhanced plot, you can see the large blue shaded area representing the CIN. That's the lid holding everything down, with over 330 joules per kilogram of convective inhibition. The atmosphere is essentially locked down right now. Now here's where things get interesting. As the desert heats through the day toward a forecast maximum of 40 degrees Celsius, we are looking at a significant transformation. The heated parcel analysis shows surface-based CAPE climbing to around 1036 joules per kilogram by this afternoon. You can see this in the pink shaded area on the heated skew-t, representing the fuel that becomes available once that hot surface parcel rises. The lifting condensation level sits quite high at 3,400 meters above ground, typical for this dry environment. We have strong deep layer shear at nearly 20 meters per second through the 0 to 6 kilometer layer, which would support organized storms if they can initiate. However, the very high cloud base means any storms that develop would have significant downdraft potential. The DCAPE of over 1,400 joules per kilogram suggests potential downdraft velocities around 53 meters per second, creating conditions favorable for strong outflow winds if convection develops. Looking ahead to tomorrow morning's machine learning forecast for late morning local time, we are seeing the atmosphere settle back down. CAPE values drop to 0 joules per kilogram with the LCL remaining elevated around 3,000 meters. Shear stays moderate near 10 meters per second. The model suggests subconvective conditions, meaning insufficient instability for thunderstorm development during the late morning hours tomorrow. For tomorrow afternoon around mid-afternoon local time, the machine learning models continue to show suppressed conditions. CAPE remains at 0 with shear dropping further to around 6 meters per second. The LCL climbs even higher to over 4,000 meters and lapse rates sit at 6.7 degrees per kilometer. These parameters indicate a stable atmosphere unlikely to support convective development tomorrow afternoon. The hodograph reveals an interesting wind profile over AEST Rock. We are seeing 0 to 6 kilometer shear of nearly 20 meters per second, which is quite substantial for supporting organized convection. The storm relative helicity values are notable, with 86 meters squared per second squared in the 0 to 1 kilometer layer and 239 in the 0 to 3 kilometer layer. The bunker's storm motion vectors show potential right-moving supercell motion if storms were to develop. This curve hodograph shape suggests that if sufficient instability materializes, any storms could exhibit rotation. However, with the high cloud bases and marginal overall instability, the primary concern would be strong outflow winds rather than tornadic development. The atmospheric refractivity profile shows some interesting features for radio propagation in the region. We can see a layer of potential superrefraction highlighted in the lower atmosphere around 1,300 meters, along with an elevated duct near 4,500 meters. These features indicate that radio signals could behave anomalously today, potentially creating extended range conditions for certain frequencies. For those operating communications equipment in the red center, be aware that signal propagation may be affected by these atmospheric layers. In summary, AEST Rock sees a marginally unstable atmosphere this afternoon with about 1,000 joules per kilogram of surface-based CAPE if the forecast 40-degree maximum is reached. Strong wind shear is present, but the very high cloud bases and dry environment favor pulse storms with gusty outflow winds rather than organized severe weather. Tomorrow looks quiet. Always consult Bureau of Meteorology official forecasts for safety decisions. This analysis is provided by Distant Curve Remote Area Telecommunications. If you found this helpful, please like and subscribe to support continued severe weather coverage for remote Australia.